Welcome back, everybody, from your networking and lunch sessions. Looking to get into a little bit more of how semantics is helping with data quality. And our next speaker, Thomas from Siemens, is going to share some experiences and stories around data cleansing for actionable outcomes. So, Thomas, the floor is yours.
Thank you very much. Excited to be here. And also thank you for everybody who joined in. So I'm going to present you, and among others, I'm leading the application field we call data readiness, which is where we develop the technology and the processes we need to make this work. So let me start with where we come from. Obviously, working with data and working with the data we have at Siemens is a key for us. It's part of our business in all across Siemens. Just to pick one example, to be able to do service for gas turbines. Looking at the process, it has been so far. We found that the types of data we're working with are a significant challenge for our businesses. So as you will see on the next slide, we are not in the fortunate situation where a big part of the data we have would be available in structured format. Rather, we're looking at what we call brownfield settings, where a significant portion of the data we need to work with is semi-structured or unstructured, be it drawings, be it documents, sometimes Excel tables, even like folders in some archive, or information being in the head of domain experts. Now, if we start to make this data accessible for machine-based work for each and every product on its own, then data labeling and data preparation will just create such huge initial development costs that in the end, it's hard to find a use case that really justifies doing all this work. And so we found out quite early that in the end, we need to look into scale effects to really make this work. So on the next slide, what you will see is the key idea why we as Siemens think we can compete in a data-driven business against cool startups, other vendors, whatever. So we are certainly, in most cases, not the company which would be developing the top-notch, leading-edge, I don't know, latest deep learning algorithm, whatever. I guess that's other players on the field. But the strength of us as Siemens, as an industrial company, is the sheer volume and breadth of data we have available, be it data about our suppliers, about engineering solutions, about plants we've constructed, of hardware products we're producing and selling. And this is really putting us in a unique position to develop data-driven services. What is, however, needed to make this work, given this huge effort for data integration that I was motivating previously, is a common approach to actually make this data available and make it accessible for the business. And as you will see on the next slide, there's 4 main pillars that we have identified to form what we call a common data foundation to streamline this access to consistent business critical data. Obviously, there's a lot about processes and policies, responsibilities, but it's also about developing shared data assets, about data services around those assets, but also, and I'll get to most of those in the later slides, about common data models that actually allow us to reuse data and share data between different assets. So with this, I would like to take you one step further from the past to the present and give you some insight how already now data cleansing as a service is helping our business units at Siemens to save cost and tackle new challenges. And all I'm talking about here is not standing for itself. It's embedded in a bigger strategy, as you will see on the next slide. And that's what we call internally our data strategy, which is basically, for us, the key to solving data integration in a way that it can scale across use cases and across our businesses. Now, obviously, we don't have the time to go into all of this, So in the next minutes, what I'll be focusing is one specific building block, which we call data cleansing as a service. And basically what data cleansing as a service is doing is getting data out of sources, bringing it into a joint model, and making it accessible for our businesses. So we have identified 4 core capabilities that we need to make this journey from what we call dark data, so data that's not accessible, to digital processing, to our use cases directly, to information that we can use right away. So looking at the input data, the first key thing we need is what we call an AI-based data cleansing service. This AI-based data cleansing service is basically looking at different data types. And at the moment, we're focusing on service documents, which are typically processed using natural language processing, layout analysis, stuff like that. But also about technical drawings, where in addition, we need capabilities such as image recognition. Also, of course, structured tables. Typical example could be Excel files, but even IoT data when we're looking at time series and events. What our data cleansing service does is extracting the information we need from all those sources, bringing this information into a common data model, where basically one challenge to solve is entity resolution. What do I mean by this? We need to find out when 2 different sources are actually talking about the same thing. Obviously, that's easy when they give the same name to the same thing. So there's like a primary key that's shared, but this isn't always the case. So on top of the extraction, one key challenge we are addressing is entity resolution, to basically find out when 2 sources are talking about the same thing. All this is then brought together in a knowledge graph, so graph database, basically. For us, that's really a key technology to make this data cleansing work, because it gives us huge flexibility in schema, in how we want to express our data, in how we also want to process data step by step. And all this is basically backed by what we call the ontology library, which is a shared catalog of data models, both shared cores, but then vertical data models that we can reuse across use cases, and this way enable reuse both on the algorithms, but also on the level of data assets we're generating. Now that's, I guess, still a bit theoretical. So on the next slide, I would like to give you one concrete example how we are applying data cleansing in a project with our colleagues at Siemens Energy. The use case we're looking at here is providing the required information for service of gas turbines. And one key requirement, basically, and we're talking about relatively small gas turbines here, so it's really a gas turbine you can take and ship to an overhaul plant and do the service there. One key requirement to be able to do this service is to have an up-to-date bill of material of your gas turbine. And while this might sound quite easy in cases where you've started constructing your turbine, I don't know, 5 years ago, and everybody already had digital data and computer-based processes in mind, this is much more a challenge if you look at historic fleets where you have turbines that have been in operations for 10 years, 15 years. If we look at, for instance, steam turbines, even longer. And so that's exactly a use case where with all the existing processes, it was a huge challenge to get this bill of material. It really involved lots of manual labor by experts going through documents, collating the information. And what we are doing with our data cleansing service here is applying the modules that I outlined before, in this case, specifically natural language processing, image recognition for processing piping and instrumentation diagrams, but also classical transformation and mapping for data coming, for instance, from SAP and Teamcenter, to extract, again, I'm emphasizing the information we need, integrate it in a knowledge graph, and then also feed the information which is our target data asset, in this case, a structured as maintained bill of material of the gas turbine, back into a target system, in this case, SAP. And this is really also a key to make this information actionable, because having it in a knowledge graph is one thing. It's nice for exploring, But in the end, what business processes depend on is having this data in the business IT system that backs the process. And so while we have this huge wealth of information of 20 years of turbine history in our graph, in the end, we're only done if we manage to bring the snapshot of information that's required for the process back into the IT system. On the next slide, I want to give you some insight into how the data that we're dealing with in the use case actually looks, and why this is not a trivial challenge. So first, looking at documents. Yes, document processing is not something we've invented, and there's really great tooling on the market. But the challenge is to take the data you extract from a document, and what you see here, for instance, is strange numbers, and give them meaning, so to turn them into information. And what's needed for that is domain expertise. So you need somebody who can help you understand how the layout affects information extraction, how a strange string you find in the document under plus modification affects your final bill of material, and on and on and on. So it's not only about extraction, but also about bringing domain knowledge into your process to really help you extract the information you need and use it to build the final data asset. A second source of information we're looking at, and you'll see that on the next slide, is piping and instrumentation diagrams. These are typically rather common in what we call the auxiliary systems of gas turbines. And the huge challenge we have there is basically, or one challenge we have there is symbol identification. Deep learning is like a classical technology to approach this problem, but we're not done there. It's about finding connections or pipes between different symbols, but also finding groupings, extracting annotations. And in the end, the target we are generating is a structured representation of the system that's depicted in the drawing. And this is then what's going into our bill of material as a part of the final data asset. So on the next slide, you see how all this fits together into what we call data cleansing as a service. Again, looking at the concrete example here for Siemens Energy, we're having all those different data sources, structured, unstructured. Data cleansing as a service pulls the data from those systems. There's typically some pre-processing steps before we can feed the information into several OCR, NLP, document processing pipelines, where, among others, we identify tables, we extract information from running text, we extract key values. And all this is then the level where the information is fed into a knowledge graph. And then on top of this knowledge graph, we're basically using both rules, so classical like if-then type of rules, but also in some places AI. One typical example would be entity reconciliation. So as mentioned, finding out that actually two sources are talking about the same thing to build the final data asset, in this case, a bill of material. And this process is already now generating really not only saving costs, but also generating additional business at Siemens Energy. And just to give you a few of the highlights, just the generation of the bonds, we have over 80% cost reduction, while at the same time having the same or partially even a higher quality than when humans are doing it. And just a few benefits of this is if it's about new quotes for sales mods, upgrades, and so on, the sales organization can do this up to 90% faster than previously, while at the same time creating better offers, which improves the hit rate and the quality of the offers we're sending to our customers. So technology is the one thing, and that's what we had a look at now. But one thing we had to learn on the go, and it wasn't always an easy learning, actually, to be honest, is technology is only a part of it. At least as important as the technology for us is the process framework that we've basically built around what we call data cleansing as a service. And obviously, yes, there's much more sub-steps, but on the big picture, we have 3 big steps we're looking at. We're starting small by specifying a pilot and running this pilot. And even there's a huge amount of process going in there, in the sense of already from the beginning, getting a clear understanding of what is actually the data asset that should be generated. What's the exact scope of the asset? And that's really important, because when we start, quite often we get the feedback, yeah, and I want all the information out of this document be extracted. But as you can imagine, what is all information? It's really hard. Just identifying what is all information requires domain knowledge, because the same string might have a different meaning depending on the position of the document. But who knows this? Only the expert, not some algorithm in itself. So already this first step is really crucially important, and that's why we're also really spending significant efforts and time in this first step to actually prepare the data cleansing service by doing a proper pilot on the data. This is typically something we even offer to our internal customers, which is the business units at a fixed price. So it's kind of a shared risk model. And we have clear acceptance criteria at the end of this first step. So already when we start the pilot, we know exactly, okay, we need to be able to extract this information. We need to bring it into that system. That's data export considerations to consider. These are the people that will finally look at the data asset and check if it meets the requirements. That's the requirements that help us judge, is the data asset good or bad? So all this is what we clarify in the pilot phase. And only after a successful pilot, we go into what we call the implementation step, where we basically take what we've done into the pilot, and based on this, realize a full service pipeline, which can be automated mostly end-to-end, I would say. What do I mean by mostly? We have a few steps in our process where we deliberately like to involve the expert. That could, for instance, be checks. So thinking back to the example with the bill of material, you might remember that on the slide, we talked about extracting modifications. Now, those modifications are the key information to build the timeline of the bill of material over time. So those modifications are something where you want to be 100% correct, that you have all of them extracted and you have them extracted correctly. So you really want to have 100% precision, 100% recall. Everybody doing machine learning knows that's not something you get in a completely automated setup. So what we're doing here is we determine how certain are our algorithms, and if we're not sure enough, we involve experts who can do a review step. Same for extraction from piping and instrumentation diagrams. The stuff works really well in the meantime. Sometimes it's impressive to see, but still sometimes people say, no, this is actually not a motor, you're wrong here, that's a pump. So we've developed some tooling around to allow people to change the interpretation of a document, which on the one hand affects the data we generate, but at the same time is fed back into a knowledge base that helps us to not make the same mistakes over and over again, but learn with every single data asset we cleanse. All this is part of our implementation step. And only when this is done, again, we have a quality gate there where we produce a number of additional assets, have them checked, make sure that we are not only not getting worse than in the pilot, but actually we're improving what was agreed at the end of the pilot that needs additional work. And then we go into a productive setup where we have this mostly automated pipeline and can really produce data assets, looking at the turbine use case, produce 10 cores a week. So 10 gas turbine cores, which is the core engine of the gas turbine, a week. And we could even scale more there. Here typically, so the implementation is typically something we cover because it's also something where we learn a lot. And then our internal benefit or revenue model is actually we charge per data unit that's cleansed. So also for a customer, it's quite easy to kind of say, okay, that's the number of turbines I have, so I know quite exactly which costs to expect. Yeah, so that's where we stand right now, but that's not the end. And so I would like to have one more look into the future with you guys. And the vision we're having is actually turning what I've now presented into a self-service data intelligence platform. Well, what you will see on the next slide is basically how we envision this again on a very high level. So the idea is the pipelines are actually the same. They're same problems we have to solve. Obviously, yes, if we have different document types, some of them require retraining. But the general pipelining of pre-processing, information extraction, information integrating using rules and or AI, and then providing the data back is the same. The key change is that we are wrapping everything into services, talking to each other via APIs. So we gain additional flexibility to allow people to push data into our pipeline instead of pulling it from the source system, and then retrieve the data from our platform back into some target application, ETL process, target system. Obviously, this also means that we need to adapt our process slightly, and that's what you will see on the next slide. The basic steps are very similar. We start with a pilot. We then implement, where it's more about implementing independent services than implementing a more monolithic type of pipeline. And then the productive setup is obviously not anymore us churning out data unit after data unit, but it's about the customer being able to kind of on demand run a certain unit through the pipeline, through the platform. And so the charging model changes slightly to a pay-per-use model for the service in the productive setup. On the next slide, I just want to give you like high-level view of the platform we are building, and our internal call it working name is the MIQ platform, where we encapsulate the whole process and the whole technology that I've been explaining so far into one piece of software that people can interact with. And just summing up on a high level, idea is, again, the platform encapsulates all the technology, all the capabilities we have developed to allow us to leverage this Siemens internal data, process the data, extract what we need, enrich the data, and then churn it out into some data system. And to be as flexible as possible, we have building up a broad basis of connectors, both for bringing data into our system, but also for providing the cleansed and enriched data to the users and to the target systems. Right, and I'm very well in time, so it took me much longer when I was doing a dry run. So on the next slide, I would like to give you a quick glimpse to also show at the current development status. So to just also show you it's not just slides, it's really software development happening there. And this is really like the current UI we're developing and we're setting up. You won't be too surprised to see, yes, we need user management, we need role management. Actually, we even need application management. What do we mean by application? For instance, the use case I've been explaining to you, cleaning a certain family of gas turbines would be an application. But we want this platform to be really generic, and it should be possible to use the same platform whether you're coming from Siemens Energy and working with gas turbines, or Siemens Energy and working with transformers, or I don't know, from our colleagues at Smart Infrastructures, and you're interested in making dark data about your buildings actionable and turning it information. All this will be covered by this one platform we're building. Yeah, if we proceed one slide, basically you already see like a glimpse of the different types of applications we're seeing. The general idea is an application that encapsulated a set of what we call pipelines that belong together. And we really give a lot of freedom, and that's what you can even see on the next slide. We give a lot of freedom for people to upload data. Now, if you look closely at the slide, you will see a lot of test PDF and farewell gift and whatever document names there. So you see, yes, this is the development system. But the idea is really people can load their data, and we're even doing our best to identify automatically what type of data is this and what's the role of this data asset in the cleansing process. So for instance, thinking about an Excel file, we can look at the structure of the Excel file. We can look at the headers. We can basically look at the schema of the Excel file and identify, oh yeah, that seems to be a design bill of material that has been dumped from Teamcenter. And this allows us to automatically basically place this data asset at the right place in our pipeline. Certainly, this doesn't always work, so people can also do this assignment manually. But again, here the idea is use automation as much as possible. And where we're not sure, ask a user, let's use the expert knowledge to be on the safe side. And then basically what user would do here, click on next, start the processing. And now I haven't brought slides on that UI with me because it's currently under active development. But what you will see under processing is basically, yeah, some of you might know NIME or similar tools. You will see a process description with several processing steps depending on each other. And in some steps, user input is required. The user will be pointed to that, where we also have built up a notification system where basically people have roles in the project. And if your input is required on a certain step, you get notified as a user that you are please requested to review, I don't know, the extraction results of piping instrumentation diagram of this and that turbine. And so we're doing our very best to build an automated platform that helps people throw in all this data they have, what we call dark data, have a largely automated process to extract, integrate, enrich, and also quality ensure a final data asset, and then bring this into production. And with this, I would like to actually close my presentation.